Good morning. So this next lesson, I'm actually going to split into 2 days. It's actually a pretty short lesson. So what I think is going to happen is we're going to have two shorter lessons spread out over 2 days, which is good because I really want to give you time to practice with this. So what we're going to do is start factoring trinomials today and breaking trinomials into two binomial factors. So let's go over a little bit of vocab first. First word is trinomial, because I threw that word out there kind of assuming that you would know what it means. And it's not difficult to figure it out. If you think of the prefix tri means three. And pretty much what a trinomial is, it's a polynomial with three terms. But we'll keep the definition to this. We'll just say it's an expression with three terms in it. Now, in order for that definition to make sense, we need to remember what terms are, and we have defined terms earlier in the year because we talk about combining like terms. So let's just kind of refresh our memory on that. Terms are expressions that are added or subtracted. As opposed to factors, which are multiplied. So you have factors which are multiplied, and then you have terms which are added and subtracted. So those are words that are useful to know because we use them all the time, and if you kind of get them confused in your head, then when I'm speaking, you might be picturing the wrong thing in your head. So examples of a trinomial might be something like this: 3x plus 4y minus 5. And how we know that's a trinomial is because we have three things that are being added or subtracted. Now, most of the trinomials that we factor aren't going to look like this. They're going to look like the quadratics in standard form that we were working with at the end of the last unit. Now, before we go into factoring, I think it's worth it to go back and talk about what it is to multiply. So this expression here is what's called a binomial. So I'll put that word over here in the corner. And if a trinomial is an expression with three terms, then if you know your prefixes, you can figure out that a binomial is an expression with two terms. And in this case, we have the two terms being x and 3. And you don't have to have the parentheses around there. Like that would be a binomial without the parentheses. But I'm going to put parentheses around it because I'm going to multiply it by something else. So I put the parentheses around it, and then I'm going to multiply it by this other binomial. So we have what's called the product of two binomials. And I'll repeat that. So the product means we're multiplying. And the things that we're multiplying are these two binomials. I'm multiplying x plus 3 by x plus 6. And the way we multiply them is with distribution. And so this is like what is sometimes called FOIL, and I know I mentioned this in an earlier lesson. So we take the x and we distribute it over the second parenthesis. So x times x gives us x squared, and then x times 6 gives us 6x. And then we take the 3 and we distribute it over the parentheses, and so 3 times x is 3x, and 3 times 6 is 18. So that is multiplication. The two factors that are being multiplied are these binomials. So sometimes math teachers, we can go off and just start talking, and we throw out all this math vocabulary and just kind of assume that our students know what we're talking about, and we say, oh, the product of two binomial factors. But all of those words individually should make sense to you. So product means the result of multiplication. Two binomial, now we know what binomials are. Factors are things that are being multiplied. So you're taking the two binomial factors, you multiply them. Now, after I multiply them, you'll notice that I have some like terms in the middle, and so I can do 6x plus 3x and get a 9x. And hopefully that does ring a bell with you from Algebra 1. Like this is definitely Algebra 1 content, is the multiplying binomials. What I'm not always sure of is if you have enough time to practice it. because remember, with factoring, the better you are at multiplying, then the easier the factoring will be. Over on the right, let's just do another example. So let's do x minus 4, and we'll multiply that by x plus 2. So we are going to distribute the x. So we have x times x, which gives us x squared, and then x times 2, which gives us 2x. And then we'll multiply the negative 4, so we're going to distribute the negative 4 times x, and negative 4 times 2. Negative 4 times x is negative 4x, and negative 4 times 2 is negative 8. And as happened in the other example, and what happens most of the time, like not 100% of the time, but the vast majority of the time, you can actually combine these two middle terms. So I have positive 2x minus 4x, and that will give me negative 2x. Now, I do this to just kind of point out a pattern, okay? If you look at the original problem and then you look at the result of the multiplication, there are a couple of things that you might notice. So one of those things is that the middle number, you can get the middle number by adding the constants. So I'll put that here. You get the middle number by adding the constants. And again, I'm throwing some math vocab out there, so I'll give you a chance to write that down. The constants are the 3 and the 6. Constants are not variables, so just plain numbers. So the middle number 9 I can get by doing 3 plus 6. So 3 plus 6 is 9. And that holds over here. The middle number, negative 2, I can get by doing negative 4 plus 2. So if you add the two constants together, you can get the middle number. The other thing you might notice is to get the last number by multiplying. So we get the last number by multiplying the constants. Multiplying the constants. So notice this, you can get 18 by doing 3 times 6, and you can get negative 8 by doing negative 4 times 2. Now, in a perfect world, you would do so many multiplication problems that you would start to recognize these patterns, and you would start to intuitively develop a sense of what you would multiply to get these trinomials in the end. Now, what we're doing in factoring is we're actually going to go in the other direction. So factoring, if you remember from the last lesson, factoring means you break up an expression into the things that were multiplied to give you that expression. So in factoring, you start with x squared plus 9x plus 18, and then you have to figure out that it was x plus 3 and x plus 6. And that takes practice. It takes knowing your times tables. It takes some patience, because sometimes you might have to bust out your calculator and do some scratch work and some division, because remember, division is related to factoring. It just takes practice. So this is not a lesson where you want to shortchange yourself on the practice. Like it is tedious. I get it. I remember doing whole worksheets of these when I took Algebra 1, just to practice. So go through a few examples here. And what I'm going to do is talk through and model the thought process, because it needs to be second nature to you. You have to know what you're looking for. If you're not sure what you're looking for, then you won't know when you found it. So this is a trinomial. What we call the leading coefficient is a 1. So if the leading coefficient is not 1, then we have to approach this a different way. And the way I'm going to teach it to you is we're going to try to bring it back to a leading coefficient of 1. And what we're looking for is what went in the parentheses that would have multiplied to give us x squared plus 9x plus 14. So we want to remember that pattern. So pretty much the x squared comes from doing x times x. So we know with the multiplication, if we kind of go back to here, we have that like x times x, And that's what gave us the x squared. Now, the middle number we get by adding the constants, and the last number we get by multiplying the constants. So what we're looking for here are two numbers. So we want two numbers that add to 9 and multiply to 14. That's what we're looking for, and that's the thought process that I will back off from doing. So when I first introduce this, I'm going to say that all the time. We want two numbers that add to this and multiply to this, or multiply to this and add to this. Eventually, though, you need to know to ask yourself that yourself. You need to generate that question, because when you're tested on this, and this skill does not go away. Like for as long as you take math, you're going to need to know how to do this. So you need to be able to ask yourself that question. So the way we usually do this is we look at the last number. We don't start with the middle number. We start with the last number, in this case, the 14. And we ask ourselves, what are the numbers that multiply to give us 14? Well, 1 times 14, 2 times 7. And what I do is I always start with 1 times whatever the number is, and then I count up. Okay, so I go like 1, 2, 3, 4, and so forth until I run out of stuff. Like there's nothing more. You start repeating the numbers. So as soon as I get to the 2 and the 7, you might recognize, wait a minute, 2 plus 7 is going to give me the 9. And that tells me that it's going to be plus 2 and plus 7. Okay, so that tells me what it is. Now, as soon as we introduce like negative numbers, like then it gets so much more fun. But like we'll start with just the positive numbers. Now, some of you, depending on how well you know your times tables, you will be able to look at this and very quickly you'll come up with the 2 and the 7. Others of you won't come up with it as quickly, and we're all going to be in different spots with that. Like the more your Algebra 1 teacher made you do this, the better you're going to be at it, the quicker it's going to come back to you. If your Algebra 1 teacher didn't make you do it, then it's going to be harder. You just, like I said, you have to be patient with yourself, maybe develop a strategy for looking at some scratch work so that you're able to just develop your own system that will work for you. Second example is x squared minus 10x plus 24. So remember, you have to ask yourself this. Two numbers that multiply to 24 and add up to negative 10. And that has to be stuck in your head. You have to make yourself say that so many times, or you'll get them switched and flip-flopped, and you won't remember what's supposed to add and what's supposed to multiply. So everything that you're going to get wrong, like you need to get it wrong on your homework. Okay, like because we got to practice this out. So they have to multiply to 24. So over here, I'm going to start listing things that multiply to give me 24. Well, I have 1 times 24, 2 times 12. And notice like my pattern here, I start with the 1 and I'm just going to work my way up. 3 times 8, 4 times 6, not 5. And then when I hit the 6, I actually already have a 6 on my list. So that's how I know I've gotten them all. Now, what's tricky about this problem is that there are actually 2 sets of numbers that you could pick to get a negative 10. And so you actually need to pay attention to the positive and the negative here. So I can get a negative 2 different ways, negative 10. I can do positive 2 plus negative 12. Okay, and that's looking at this combination here, the 2 and the 12. You can get a negative 10 by doing a positive 2 and a negative 12. You can also get a negative 10 using the 4 and the 6 by doing negative 4 plus negative 6. So now we have to decide which one of those is the one that gives me this trinomial. And to figure it out, you've got to really pay attention to the 24. When you multiply them, you need to get a positive 24. So if I do positive 2 times negative 12, I'll get a negative 24, and it won't work. So that is going to eliminate that option. If I have negative 4 times negative 6, that will give me the positive 24. And so we have negative 4 times negative 6. And that is like really awful parenthesis. I can do that better. There we go. All right, last example. we have, seriously, x squared plus x minus 12. And remember that you've got a 1 right there, okay? So when you don't see the coefficient, it's a 1. And this, again, this is what you have to train yourself to ask. What are two numbers that multiply to negative 12 and add up to positive 1? Multiply to the c, add up to the middle number. Multiply to the last number, add up to the middle number. And always start by thinking about the numbers that will multiply to that middle number. So I'm going to look at 12, and I'm going to start listing the numbers. 1 times 12, 2 times 6, 3 times 4, and then when I hit the 4, I already have a 4 on the list. So now, which one of these pairs can get me a positive 1? Well, I can't add or subtract 1 and 12 in any way. That's going to give me a 1. Like I can do 1 plus 12 and get 13, or I can subtract them and get an 11, but 2 and the 6 doesn't work. If you add them, you get an 8. If you subtract them, you end up with a 4. But the 3 and the 4 could work. If I make the 3 negative and the 4 positive, that's how I can get the positive 1. Negative 3 plus 4 is positive 1. And then go back and check that multiplication. Make sure that you haven't messed up the sign on the multiplication. Negative 3 times positive 4 will give you negative 12. And so in our parentheses, we would have negative 3 and positive 4. So a couple of things about this. Multiplication is commutative. And what we mean by that is that, well, here's what commutativity is. So these words that come back from the beginning of the school year, like they're important. So what we mean by that is like 2 times 5 is the same as 5 times 2. Okay, and they're both 10, and I know you all know that. What that means for us in this lesson is that if you have x plus 2, x plus 7, that is the same thing as x plus 7 times x plus 2. Because remember, this is just multiplication in between there. That's the operation that's happening. And so the same property that allows you to switch the order on the just numbers also allows you to switch the order on your binomial expressions. And that's because math is consistent and the rules stay the same. Now, there are a couple of little things that you'll notice as you do lots of factoring problems. So here's what I mean by that. You'll notice as you do a lot of factoring problems that there are certain patterns that can help you reduce the number of things that you're trying to guess. If the last number in your trinomial is a positive number, so you have x squared, blah, 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 plus something. Like here, x squared minus 10x plus 24. The signs are going to match. In other words, you will either both have, you have both negative or you'll have both positive. And the reason for that is because that last number comes from multiplying them, and you know that a negative times a negative will give you a positive, and a positive times a positive would give you a positive. So if you see a plus something, it just means that whatever you have, pluses or minuses, they're both going to be the same. If the last number is negative, then the signs will be different. So in the example with the negative 12, the negative 12 comes from multiplying the last two numbers, and in order to get a negative, one of them has to be negative and one of them has to be positive. So there are some things that you can do to just kind of make it a little bit easier on yourself, and the more you do them, you'll start to notice those patterns. Now, I'm going to skip over the practice problems just for a minute, and that's only because I'm doing a video here, and I just want to clarify what it is to check your answers. You check your answers by multiplying. And one of the things that students do tend to get wrong is they tend to confuse the factoring with the checking. So let's say you have this problem. You have x squared plus x minus 6. And you factor it, and you get x plus 2, x minus 3. Okay, so you're like, okay, they need to multiply to negative 6, and I have a plus 2 and a minus 3. And you go to factor it. This is the factoring, okay? And there really is no work that you're going to show. You're going to go straight from the trinomial to the answer. So this is not a skill where you're going to have to show any work at all. You're going to have to think, but you're not going to have to show any work. If you wanted to check your answer, the checking of the answer would happen somewhere else, okay? It's going to happen off to the right. I want you to label it as the check. I do not want your check to run right through like your problem. So I'm going to check this by multiplying it because factoring and multiplying undo each other. So I'm going to distribute the x squared. X times x is x squared. X times negative 3 is negative 3x. And then I'll distribute the 2. 2 times x is 2x, and 2 times negative 3 is negative 6. And then the middle ones combine. Negative 3x plus 2x is negative 1x. And what we notice here is that it actually doesn't check. I have done it incorrectly. And the way I know it doesn't check is because I got a minus x, and what I wanted to get was a plus x. So just notice where I'm kind of dragging the cursor across the screen here. This actually does not check, and it's my way of knowing that I factored it incorrectly. Now, with practice and experience, you will actually get very good at fixing this. If you get the right number, but the wrong sign, okay? So in this case, we got the number 1. We have negative 1, but we wanted positive 1. So when that happens, like you have the right number sitting there, but it's opposite sign, the way you fix that, and here's what I'm going to do. I'm just going to draw a line right through that answer there. And it's going to be x minus 2 and x plus 3. So if that happens, you just need to flip-flop your signs. So if you have a plus, make it a minus. If you have a minus, make it a plus. If you have 2 minuses, make them both pluses. If you have 2 pluses, make them both minuses. You're just going to flip the signs. So that's like one of those mistakes that once you see it a few times, you'll know how to fix it. But this is not part of the problem. This is the check for the problem. All right, without any further ado, let's get to some practice work. And here they are. X squared minus 8x plus 15, x squared plus 4x minus 12, and x squared plus 10x plus 25. That's kind of a jacked up plus sign. Sorry about that. So just try to factor these. Be patient. If you get them wrong, just do the checkout, multiply them, and if they're wrong, try something else. It's really the only way to get better at them. And for those that might be making up this lesson on their own, here are the answers. So this would be x minus 5, x minus 3. And if you wrote down, that's like still horrible. I can't handle that. There we go. That's a little bit better. If you wrote down x minus 3, x minus 5, that's the same thing because multiplication is commutative. The second one is x plus 6, x minus 2. And the third one is x plus 5 times x plus 5, or you might write it x plus 5 squared. And x plus 5 squared, because that's what it is to multiply something by itself. And that concludes our first lesson on factoring trinomials.